so much for joining us today in Mathcon universe and the wonderful world of mathematics. Today, our focus will be on strategic problem solving in key concept of absolute value linear algebraic inequalities, part 2. I repeat, our focus will be on strategic problem solving in key concept of absolute value linear algebraic inequalities, part 2. Let us go ahead and get started immediately. So what will be our first step in this strategic problem solving process? Our first step will be to use the distributive property. Step number 1. The distributive property. Let us see. In other words, if we have A into B minus C, this means that we can say that A times B minus A times C. Again, if we have A into B minus C, this is the same thing as A times B minus A times C. So in our problem, A will represent 4, B will represent X, and C will represent 2. Therefore, we have 4 times X and then 4 times negative 2. So what is 4 times X? What is 4 times X? Well, 4 times X is 4X. And what is 4 times negative 2? What is 4 times negative 2? 4 times negative 2, of course, will be negative 8. Negative 8. Then we need to bring down the negative 6. Bring down the inequality symbol, and then bring down the 10. So in this case now we have the absolute value of 4x minus 8 minus 6 less than 10. So what will be our next step in this strategic problem solving process? What will be our next step? Our next step, of course, will be to combine the like terms inside the absolute value symbol. So we are going to combine negative 8 and negative 6. So what does it mean to combine like terms? Well, to combine like terms means what? To bring things that are alike together. Things that are alike together. So that will be our step number 2. Combine like terms. So therefore, our like terms, of course, will be negative 8 and negative 6. So what is negative 8 minus 6? Negative 8 minus 6. Well, negative 8 minus 6 will be negative 14. So therefore, we have here absolute value of 4x, absolute value of 4x minus 14 less than 10. absolute value of 4x minus 14 then will be less than 10. So what will be our next step in this strategic problem solving process? Our next step is very, very important. So pay close attention. Our next step will be to use what we'll call absolute value rule. Use the absolute value rule. Absolute value rule. In this case, let's call this type 2. What does it say? What does the absolute value rule type 2 say? It says that if the absolute value of the number k is less than t, the absolute value of the number k is less than t, then negative t, rather, will be less than k, and k will be less than t. I repeat, according to this rule, the absolute value rule, very famous rule of course, if the absolute value of k is less than t, then the negative of t will be less than k, and k will be less than t. So let us apply this important rule to this problem. Let us apply this rule to this problem. If we do so, we will be able to obtain negative 10 will be then less than 4x minus 14, and this will be now less than positive 10. That will be less than positive 10. So in this case then, the 4x minus 14 represent the k, and the number 10 represent the t in this absolute value rule. So let us then proceed now to solve the compound inequality that has been generated from this situation. So we have negative 10 less than 4x minus 14, and this of course will be less than the number 10. So what would be our strategy for solving a problem like this? Well, notice the goal is to solve for x. Our goal is to solve for x. So what we must have to do then is to try to eliminate negative 14. And how do we do this? Well, one key thing we can do is to add the opposite of negative 14 to all sides of the inequality. So in this case, of course, that number will be positive 14. So as I add positive 14 to this part of the problem, I must also do the same thing to the right side. And then I must do the same thing to the left side of the expression in the middle of the inequality. So that will be 14 as well. Notice that if I do so, that this negative 14 will cancel out with positive 14. And of course, we know that negative 14, positive 14 rather, minus 10 will be what? Positive 14 minus 10 will be what? Will be, of course, the number 4. And of course, we're now going to bring down what? The 4x here. Then notice on the right side, we're going to add the 10 to the 14, and we're going to obtain the number 24. So what will be our next step in this strategic problem solving process? What will be our next step? Of course, notice that 4x is what we have here, but what we desire is x, is the variable x. That's what we're solving for. So we want to have x here in the middle. How do we obtain that? Well, we need to divide, of course, it by 4. We must divide the 4x by 4 to be able to isolate x. So whatever you do to one side of the inequality, in the case of a compound inequality like this, you must do it to all sides. If you do it to one side, you must do it to all sides. So that means we're going to divide everything here by 4. So notice that this 4 will cancel out with this 4, and we're going to obtain 1. And 4 into 4 here, of course, is 1. And of course, 4 into 24 is going to be 6, because 6 times 4 is 24, and 4 into 4 is 1. So consequently, therefore, we are then going to obtain the number 1 less than x, and x will be less than the number 6. So this will be a solution to this inequality, to the absolute value inequality. This will be the solution. The sense that the solution will be every number that is between 1 and 6. Numbers that are greater than 1 but less than 6 are solution to this absolute value inequality. So what will be our next step to finish up this problem? Our next step will be to graph the solution on a real number line to obtain what we call the graphical solution to the absolute inequality problem. To obtain the solution to the absolute value inequality problem, the graphical solution. So let us do that now. The graphical solution. On the right, of course, of 0, on the right side of 0, we're going to have the positive numbers. So here we get the number 1, number 2, number 3, the number 4, the number 5, the number 6, the number 7. On the left side, of course, we're going to have -1, -2, -3, -4, -5, -6. So notice our goal, of course, is to graph this solution of the absolute value inequality. And we note that all numbers between 1 and 6 are considered the solution to this inequality. So let us locate these numbers on this number line, the real number line. First of all, take the number 1 and notice that 1 is not the solution. And take the number 6 and notice that 6 is not the solution. But every number between 1 and 6 is considered a solution. Every number between 1 and 6 is considered a solution. So this is the graphical solution to the graphical solution of what? The graphical solution of the absolute value inequality. The linear absolute value inequality. I hope that you have learned some lessons, valuable lessons, of course, about how to solve absolute value linear algebraic inequality. Type 2. Type 2. And I would like to encourage you to continue to practice this type of problem more and more. The more you solve this type of problem, the more proficient you will become in solving problems of this type. And the more you will be able to build your problem-solving confidence, as well as the ability to develop a strong knowledge base in algebra and, of course, in mathematics in general. Thank you so much once again for joining us in the wonderful world of mathematics and Mathcon universe. Until next time, goodbye.